Welcome to Lab 5 on relative time. So the material is posted on Canvas, and this video is to help those of you who were unable to meet with us in class. I want to share my screen. There are some images I want you to see. Let's see if I can flip to the correct one. So you should have printed out a PDF that had a series of 3 drawings on it. And we want to talk about these 3 drawings. We'll do them individually. So let me pull up the sheet where I actually have that material in place. So we'll start with cross-section A. So what we have are 4 kinds of rock. We have conglomerate, and then on top of that is arkose, and then on top of that is shale, and at the very tippy top is limestone. Most layers of rock get deposited horizontally, and then over time changes take place. In a cross section, in a side view, what you see are some of those changes. So on this particular sample, we see the wavy line at the top, and then there's another one buried inside. These wavy lines are unconformities, and they represent breaks in the geologic record. So maybe there was a river that ate away some rock, or maybe there was a glacier that came in and dragged away some rock. The point is that below the unconformity and above the unconformity, the rocks differ dramatically in age. They're very different in age. So to come up with a geologic column, a sort of historical representation of the order of events, we start out by listing the rocks in order with the youngest on top. So if we look at our layer, we started out with limestone, then we went to shale, and then to arkose, and we ended up with conglomerate. And so off to the side, down here, I've written those 4 rocks in order with the youngest on the top and the oldest on the bottom, and it should match the layers as we go down. The second thing we need to do is we need to take our list and we need to insert any changes to the layers. So are there any dikes or sills? Are there any unconformities? Are any of the rock layers tilted, etc.? So when we look at this, there are no dikes or sills. We don't see any igneous intrusions. None of the rock layers have been tilted. And so the only thing we've got are 2 unconformities. We have one at the very top, so it would be inserted right here above the limestone. And then we have one between the arkose and the shale. And so to show you what it would look like if I inserted them, I would draw a little arrow out to the side and then write the word unconformity. And now to put the rocks together to form the geologic column, we start at the top and we work our way down. So this top unconformity would be the top layer, followed by limestone, followed by shale, then the second unconformity, followed by arkose, and then the conglomerate. And if we list all of those, we have 6 events: the top unconformity, the limestone, the shale, the unconformity in the middle of the layers, the arkose, and the conglomerate. And then we number them. 1 is always on the bottom and the biggest number is on top. So we go 1 through 6 for this particular cross section. Let's look at the second drawing. So your second drawing, we have the same kinds of rock, and in fact, they're in the same order, but different events have taken place. So it looks like the previous drawing, except different events have taken place. We have a wavy line on top. Well, we know that's an unconformity, but we have 1, 2, 3 layers that are at an angle. And so those 3 layers are tilted. They didn't get tilted individually because the lines that separate them are nice and straight. So they were tilted as a group. So that means the conglomerate, the arkose, and the shale were deposited, and then the tilt came in, and then finally the limestone got deposited, and then on top of that is our unconformity. And so if we do our little drawings, we've got the top unconformity, the limestone, and the tilt telling us that the 3 layers below it were all tilted as a group. And so when we list our layers to make the geologic column, we start at the top and work our way down. So unconformity, limestone, tilt, shale, arkose, conglomerate, and we number them starting at the bottom. 1 at the bottom, and in this case, 6 at the top. The oldest rock is always layer number 1. It's like children in a family. And the last cross section is a little more complicated. So on this one, the same rock layers, the same 4 rocks, but we have an unconformity in the middle, and we have a dike sill combo. So we have our 4 layers listed the way they were for the previous 2 examples. We just need to insert the 2 changes. This dike sill combo happened at one time, but we ignore the sill and we look at the part that extends the highest up. And that's the part that cuts into the shale, the dike. And that tells me that the dike was in place and then we intruded into it. So the dike sill combo has to come after the shale. So the shale gets deposited and then the dike sill combo will occur right here. And then we've got also an unconformity right there. If you have 2 things happening at the same place, which we do between shale and limestone, what you do is the unconformity is by default the younger event, so it'll be closer to the top. Unconformities are surface events, so they occur closer to the top. So we've got our dike sill combo and our unconformity taking place between limestone and shale. And so you can see that I've got 2 little arrows coming out. The dike sill combo is the lower of the 2. The unconformity is the higher of the 2. And when we do our geologic column, we would start out with limestone, then go unconformity, then dike sill combo, and then shale, arkose, and conglomerate. We would number them going 1 through 6. You probably want to keep this information handy for the actual lab itself, but I'm going to stop the video and stop sharing.